Now we're looking for any x from any number system. Remember, the complex numbers is the all-encompassing number system. The real numbers are a subset of the complex numbers. Let me make that fancy they can see there. Okay. So C stands for the complex numbers. Numbers are in the form a plus bi where you have an imaginary part. Now a real number is a complex number with just a zero imaginary part. So the real numbers are a subset of the complex numbers. So this is our way to just find all x. A lot of channels leave this kind of stuff off. You may have pure complex numbers with non-zero imaginary parts. You may or may not. But anyway, here we go. Now, this thing begs for a factorization, which we do on this very next line. You can see x plus 3 times x plus 4 is this, and so on all the way across. This bottom line right here is just, or this line directly underneath is just common denominator. And then we expand it out. The common denominator is just the product of all the denominators that you see. There's some overlapping with the denominators. And then when you simplify this numerator, you get 3x squared plus 27x plus 60. But notice something very nice happens right here. 3 factors out, and what you end up with is, notice that I'll underline this object, and I try to put it directly underneath. X plus 4 times x plus 5 is exactly x squared plus 9x plus 20. Okay, so as long as x is not equal to negative 4 or negative 5, those two factors cancel. And what you end up with is this result. You have 1 over 6x, okay, time or equals. Now again, as I mentioned, these two objects are the same thing. So you have 3. And let me go ahead. I don't know if it's necessary to multiply this out or not. I guess it wouldn't hurt. So I'm going to, rather than write down x plus 3 times x plus 6, I'll write down x squared. What do we get? 9x plus 9x plus 18. Okay, and again, folks, this x plus 4 times x plus 5 canceled with the parenthetical expression directly above it. X plus 3 times x plus 6 gives you this. Okay, now what can we do here? Let's see here. This would be, if you look at this, if you invert and divide by, multiply by 3, let's see what happens here. You would have, let's just write it down. Okay, so we could write down 6x. If two fractions are equal to each other, the reciprocals are equal to each other. So you would get this x squared plus 9x plus 18 over 3. All right. And then what happens here, ladies and gentlemen, don't we end up with, again, we inverted and multiplied, so this will give us, what, 18x? So we end up with 18x. When you take it away from this side over here, you'll end up with 0. And stay with me here, see if I'm making mistakes. 0 is equal to, so I'm going to go 3 times 6x is 18x, then take it away from this 9x. And so we get x squared minus 9x plus 18. Okay, folks? And of course, this appears to factor. We end up with, this is equal to x minus 6 times x minus 3, right, ladies and gentlemen? Okay, equals to 0. And of course, that intimates that x is either equal to 6 or 3. No need to check any of this. It's all reversible. So those are our two solutions, folks. Now, they're just integer solutions. But remember, an integer can be written, like you can write it as 6 plus 0i. So it is a member of the complex numbers. I was just making sure you found all the solutions. There are no, there's just these two integer solutions, unless I made some sort of grave error in my calculations right here. So we get x equals 6 and 3. Let's come up here. X equals 2. 6, comma 3. It's common in a lot of math classes to write them in solution set form, so we can write 6, comma 3 as the solution set. Because there's some logician just right around the corner who's saying you can't have x equal to 6 and 3 at the same time. But anyway, this is solution set, okay? And this is a more advantageous way to write the answer if you have a higher degree situation going on right here. But it is somewhat surprising. This looks like just a horrible situation to be in, but we had a circumstance where when we factored, we actually had a chunk that canceled with a big part of the denominator. That's what made this thing tractable. If it doesn't, what do you end up with, a quartic equation or something? But anyway, that's it. That's it, folks. X equals 6 and 3 are the two and only two solutions. By the way, I try to check those if you want to have fun. Okay, because you end up with some crazy, this would be, for 6, you would have 1 over 36. You have to check all this. So it's quite an exercise in arithmetic. But I don't believe, I guess people want to see the checks, but we didn't do anything that would introduce extraneous solutions. Okay, we didn't square or anything like that. When we divided out, we always, like right here, when we did this cancellation right here, we were assuming that x can't be -4 or -5, which is impossible anyway because -4 and -5 can't be in the solution domain to begin with if you just look at it. So that cancellation is totally justified. No possibility of extraneous solutions here. Okay, thanks for viewing.